What if the universe was never meant to make sense, only to be survived? You were taught that science is solid, that it's built on laws, constants, rules. But the deeper we look, into particles, into time, into the very fabric of space, those rules begin to tremble, equations bend, observations change reality, and logic collapses. This isn't science class. This is the side of discovery where certainty dies. You're about to enter a space where black holes remember, light refuses to obey, and particles seem to know you're watching them. Each paradox in this journey isn't just a riddle, it's a quiet rebellion against everything we thought we understood. A whisper from the universe saying, "You were never meant to understand me, only to feel me unravel." So lay back, close your eyes, and let the edge of reason dissolve as we walk through 25 paradoxes, each one a crack in the glass of reality. Because sometimes the truth doesn't set you free, it leaves you weightless. There was once a star that lived for billions of years. It burned with the light of ancient hydrogen, fused into helium, and eventually into iron, the element that spells doom for all stars. And when its time came, it didn't just die. It collapsed into something that shouldn't exist. A point of infinite density, a place where the laws of physics dissolve, a black hole. But this isn't just about stellar death. This is about something more chilling. Because the deeper we looked into that collapse, the less we understood. The gravity was infinite. Time slowed to a crawl. And at the very heart of that black hole was a question we still can't answer. Star that collapsed into a question. Black holes are born from mass, but they erase mass. They come from information, but they destroy information. At least they're supposed to. That's the paradox. According to Stephen Hawking's calculations, black holes aren't completely black. They emit radiation and can slowly evaporate over time. But if they do, where does all the information go? The atoms, the patterns, the quantum states that define the thing that fell in, are they erased, scattered, transformed? Because in physics, information is sacred. It's the blueprint of reality. Every particle, every position, every spin and velocity, it's data. And that data can't just disappear. It has to go somewhere. Otherwise, everything we know about quantum mechanics begins to unravel. So when that star collapsed into a black hole and its information was seemingly lost, a deeper question emerged. Can information ever truly vanish? Or does the universe somehow remember everything forever? This is known as the black hole information paradox, and it's one of the most profound scientific puzzles of our time. It pits the rules of quantum mechanics against the rules of general relativity. Both systems work, both have been tested, but together they break. A singularity at the center of a black hole is not just a place, it's a breakdown. A collapse not only of matter, but of knowledge, of certainty, of continuity. And what could be more terrifying than that? Because if a star, an entire massive, luminous being, can reduce itself to a question mark, what does that say about the rest of us? What happens when you reach your own point of collapse? When your beliefs, your memories, your identity become too heavy to hold? Do you vanish into something unknowable, or is there a deeper layer, one that retains your essence in a way you can't perceive? Perhaps that's what a black hole really is, a mirror to our limits, a reminder that not every mystery has an answer. Some truths are too dense, too compressed to ever be unraveled. Some questions don't dissolve because they're unsolvable, but because the act of asking is the dissolution. And here's what's even stranger. Some physicists now believe that black holes do preserve information, just not inside. They propose that the surface of the black hole, the event horizon, stores everything that falls in. That somehow, all the data is smeared across that edge like a hologram. A projection, a memory that exists only on the boundary between being and non-being. So now we're faced with another question. Is the universe itself a hologram? Is everything you know, everything you are, just a projection on the edge of a deeper, unknowable dimension? The star that collapsed into a question asks more than science can answer. It demands we look at the gaps in our models, not as failures, but as thresholds. Not everything that breaks is broken. Some things are meant to collapse, because only through collapse can something else emerge. A black hole is not just the death of a star. It's the birth of a paradox. It is where science stops pretending it has it all figured out. And maybe that's what we need more than anything. Not more answers, but more humility. The willingness to say, we don't know. And maybe we're not supposed to. Because a question that can't be answered isn't a failure. It's a signal that we've reached the edge of the map. And beyond that edge is something vast, waiting to be asked. You've been told that time moves forward, that it flows like a river from past to present to future, that what's done is done, and what hasn't happened yet is still on its way. But what if that's not true? What if time isn't a river? What if time is a mirror, and the moment you look into it, the image shifts? Time that moved backward when watched. This paradox doesn't begin with imagination. It begins with reality. In the strange world of quantum mechanics, particles don't always follow the arrows we assign them. In 2019, a team of physicists performed a real experiment that seemed to reverse the flow of time. At least for a quantum bit, or qubit. They used a quantum computer to return a qubit to its previous state. In simple terms, they undid time for a single particle. Of course, it's not time travel the way Hollywood shows it. No DeLorean, no wormhole. But what it implies is far stranger. Because what the experiment revealed wasn't just that you can nudge a system backward under the right conditions. It hinted at something more fundamental, that time at the quantum level might not even have a direction at all. Let that sink in. At the smallest scale of existence, time doesn't move. It waits. It doesn't push things forward. It just holds the potential for movement. And it might go either way, forward or backward, depending on how you interact with it. You were taught that watching something doesn't change it. But in quantum physics, observation is not passive. It's aggressive. It collapses possibilities. It defines outcomes. And in doing so, it might be dictating which direction time flows. Imagine this. There is a particle in a quantum state, uncertain, undefined. It could evolve forward or in reverse. But the moment you measure it, you choose its timeline. You're not just watching time, you're selecting it. This is the uncomfortable heart of time that moved backward when watched. Your attention changes. Reality. Not just spatially, but temporally. Now widen that idea beyond particles. Apply it to your own life. Have you ever looked back at a moment in your past and realized it meant something completely different than you thought at the time? That a single memory, once benign, now haunts you? Or a painful event, once unbearable, has become a source of growth? You didn't change the event. You changed the timeline. You rewrote what it meant. That's the personal version of this paradox. The act of watching your past differently bends its trajectory. Maybe time has never been linear. Maybe it's a sphere, or a spiral, or a tightly wound string, waiting for you to pluck it in just the right place to make the whole thing vibrate backward. Here's another layer. Scientists have begun exploring the idea of retrocausality, the concept that future events might influence the present or past. It sounds like science fiction, but it's grounded in attempts to explain strange quantum behaviors. If time is symmetrical at the quantum level, then why should causality only work one way? This doesn't mean you'll wake up tomorrow and uneat your breakfast. But it could mean that the universe is less like a script and more like a conversation. One where the future is constantly whispering back to the past, shaping its lines, changing the rhythm. And if that's true, then you are not a fixed being. You are an unfolding equation, one whose variables aren't just determined by what has happened, but also by what might. The decisions you haven't made yet might already be affecting the person you were. You are not only the echo of your past, you might be the foreshadow of your future. The time that moved backward, when watched, is more than a paradox. It's a challenge, a dare, to stop thinking of time as a prison and start seeing it as a collaborator. The past is not dead. The future is not unborn. They're entangled, interwoven, mutually unfinished, and maybe, just maybe, if you learn to watch carefully enough, you'll start to notice something strange. The clock isn't ticking, it's listening. Somewhere, someone once wrote an equation that wasn't meant to be solved, not because it was impossible, but because it wasn't the equation that needed solving. It was you. You were taught that equations are tools, that they describe things, gravity, motion, light. But what if one day you came across a formula so vast, so recursive, so infinitely complex, that the more you tried to solve it, the more it solved you? Equation that solved you instead. This isn't abstract metaphor. It's grounded in the ongoing quest for a theory of everything, a single unified equation that explains all the forces in the universe. Gravity, electromagnetism, the strong and weak nuclear forces. Physicists have hunted it for decades, trying to unify quantum mechanics and general relativity into one perfect model. But here's the paradox. The closer they get to this ultimate equation, the more reality resists simplification. The numbers grow stranger, the dimensions multiply, and the very act of seeking a perfect model begins to distort what you're modeling. In theoretical physics, equations aren't just about numbers, they're maps of existence. But maps change depending on how you read them. Look too closely, and they collapse under their own precision. Pull back too far, and everything blurs into meaninglessness. It's as if the equation is aware of you, as if it adapts as you approach it. Think of Gödel's incompleteness theorems. He proved that any formal mathematical system complex enough to include basic arithmetic will always contain true statements that cannot be proven within that system. In other words, you can never fully understand the system from within itself. So, what happens when the system you're trying to understand is you? You are made of particles, fields, probabilities. Your thoughts are electrical impulses. Your dreams are data flowing through neural networks. You are, at the deepest level, a biological equation running in real time. So when you try to solve the universe, what are you really doing? You're writing an equation to explain the equation that is you. And somewhere in that loop, things start to break. That's the heart of the equation that solved you instead. It's not just recursive, it's existential. Maybe the equation isn't written on a chalkboard. Maybe it's written in your fears, in your longing, in your need to make sense of things that refuse to hold still. You've felt it before, haven't you? That moment when you're trying to explain something, love, consciousness, memory, and the explanation begins to feel cold, empty, as if reducing it to logic kills the very thing you were trying to touch. That's the paradox. The more you try to contain truth within symbols, the more it slips away. The moment you write it down, it ceases to be alive. And yet, we keep writing, we keep solving. But this equation is different. This one reflects you back at yourself. It doesn't ask for numbers. It asks for vulnerability, for awareness, for surrender. It begins simply. What is real? It continues. Who are you without your memories? Then it sharpens. Are your thoughts truly yours? Or are they patterns passed down through generations of unexamined minds? And then the real question appears. If this equation is solving you, then what's left when it's done? Are you the answer or the remainder? Here's the final twist. Some modern physicists believe the universe itself may be a kind of self-computing machine, a vast, recursive algorithm, not running on hardware, but as hardware. You're not in a simulation. You are the simulation. The equation isn't outside you. It's everything you touch, everything you feel, every breath you take. You're not holding the question. You are the question. And the more you search for an answer, the more that answer becomes you. So beware the next time you try to understand too much. The next time you seek perfect knowledge. Because some equations don't give you clarity. They give you exposure, and when this one finishes its work, you may find that it hasn't explained the universe at all. It's only stripped you of the illusion that you were ever separate from it. Far beyond your reach, past the haze of local stars and the dust of forgotten solar systems, there exists something that shouldn't be. A galaxy, vast, luminous, spinning elegantly through space, but missing something essential. Its mass. It orbits, it rotates, but not in the way the laws of physics demand. Something is off, wrong, impossible, and yet there it is. Galaxy that spun without mass. When astronomers first began measuring the rotation speeds of galaxies in the early 20th century, they expected the stars near the edges to orbit more slowly than those near the center, much like how planets closer to the sun move faster. But what they found shattered expectations. The outer stars were moving just as fast as those near the center, sometimes even faster. This made no sense, unless there was something else at play, something massive, invisible, and everywhere. Thus, dark matter was born, a placeholder, a necessary lie, an invisible substance that made the math work. It had to be there. Otherwise, the galaxies would tear themselves apart. The spin would fling stars into the void. But here's where it gets stranger. In 2018, scientists discovered a galaxy that appears to contain no dark matter at all. It spins. It behaves like a galaxy, but without the gravitational glue we assumed was essential. It defies the very rules dark matter was invented to explain. If dark matter is real, how can a galaxy like this exist? If dark matter isn't real, then why do most galaxies behave as if it is? This paradox, galaxy that spun without mass, isn't just about celestial mechanics. It's about what we invent to make sense of chaos. It's about the unseen scaffolding we rely on to keep our models upright, and what happens when that scaffolding vanishes. Because sometimes, it's not the absence that's frightening, it's the presence that never was. Think of how often you build invisible structures around your life. Beliefs, identities, explanations for why things are the way they are. He didn't love me because I wasn't enough. She left because I was broken. I failed because I always do. These are your dark matter, unseen, unmeasurable, but powerful. They hold your inner universe together. They explain the spin. But what if they're wrong? What if the thing holding your life in place was never there? This galaxy, this rogue system of stars, is a cosmic mirror. It says, you can spin without the things you thought you needed. You can orbit without the old gravity. You can exist without the invisible weight you've carried for years. But it also whispers something more unsettling. If one galaxy breaks the rule, what if the rule itself is broken? This single discovery has sent ripples through cosmology. Some physicists believe it's proof that dark matter isn't what we think it is. Others argue it's a misreading, a glitch, a fluke. Because if we accept it, we might have to rewrite everything. That's the true terror of paradox. Not that it defies what we know, but that it forces us to admit we were never sure to begin with. Galaxy that spun without mass isn't just about astronomy. It's a reminder of how fragile knowledge can be when it rests on shadows. Science is a process, a beautiful one. But sometimes its elegance masks its uncertainty. We think in terms of certainty, but the universe doesn't care. It behaves, and sometimes it behaves in ways that laugh at our laws. So what do you do with that? When the models collapse, do you collapse with them? Or do you learn to spin anyway? This galaxy is not just an object of study, it's a challenge to your intellect, to your confidence, to your certainty. Because maybe the most dangerous kind of gravity is the one in your mind. The force that keeps pulling you back to the same explanations, the same assumptions, the same self-doubt. Let this galaxy teach you something. You don't always need proof to let go. You don't always need mass to move. You don't always need dark matter to shine. Sometimes, just existing outside the model is enough to break it. And sometimes that's the only way anything new ever begins. You've walked roads in life where each choice felt irreversible. You took one path and the others disappeared. You assumed the world worked like that, linear, logical, consequence-driven. But then came the electron, and it didn't just break that logic, it ignored it entirely. Electron, that traveled every path but one in the quantum world, reality does not behave the way we were taught. The Feynman path integral formulation, one of the most mind-bending concepts in quantum mechanics, states that a single electron doesn't just take a path from point A to point B, it takes every possible path at once. It arcs across the sky. It burrows through the Earth. It loops around Saturn. It even travels backward in time. The electron explores all of these trajectories, simultaneously, infinitely, every path the universe allows, until the moment it's observed. And only then, only in that instant, does it collapse into a single outcome, a location, a decision. And here's the twist. The one path it never takes is the one we expect. The path that seems obvious or normal. That path is erased by the interference of all the others. The predicted route is the only one that disappears in the quantum wash. Let that unravel in your mind. The electron chooses every option except the one you thought was inevitable. The electron that traveled every path but one is not just a scientific oddity. It's a metaphor for your own existence. You live your life assuming you're bound by what's most likely, what's expected, what's safe. But what if the truest version of you is always hiding in the improbable, the irrational, the paths you dismissed without walking? Quantum physics teaches us that the universe doesn't reward predictability. It thrives on potential, on superposition, on probabilities that refuse to collapse until they're forced to. So ask yourself, what choices in your life have you already ruled out? Not because they're impossible, but because they don't fit your narrative. What paths have you never walked because you assumed they wouldn't work? The paradox of the electron says, those might be the very roads that define you. This quantum behavior is what makes electrons, photons, and other particles so beautifully unpredictable. It's why quantum computing, quantum cryptography, and teleportation exist as scientific frontiers. Because reality at that level is not deterministic, it's plural. And yet, you are made of these particles. You are a walking cloud of probabilities, collapsing into form moment by moment. So what if your thoughts, your dreams, work the same way? When you imagine a life you didn't live, a person you didn't become, a choice you didn't make, maybe those aren't fantasies. Maybe they're echoes, possibilities that are just as real, just waiting to be observed. The electron that traveled every path but one challenges the illusion of a single destiny. It erodes the idea of a fixed identity, and it dares you to embrace the uncomfortable truth that your most expected outcome might be the least likely to manifest, and the path you thought was too strange, too far, too uncertain, might be the one you were always meant to take. So what do you do with that? How do you live in a universe where every choice is simultaneously real and unreal? Until the moment you look. You surrender, not in defeat, but in wonder. You stop clinging to the idea that your story must unfold in straight lines. You begin to trust the detours, the delays, the accidents that weren't accidents, the irrational impulses that led you somewhere better than logic ever could. And maybe that's the only way to truly live in a quantum world, to stop chasing certainty and start dancing with possibility, because the electron didn't fail when it skipped the obvious path. It simply honored the truth that the universe is never what you think. Light is supposed to be the fastest thing in existence, a cosmic speed limit, the ultimate messenger of time and distance. You flick a switch and the room responds instantly. You look up at the stars and their light reaches across galaxies. To touch your eyes, straight lines, no hesitation. But sometimes even light takes its time, and not because it has to, but because the universe lets it. Light that took the longest shortcut. There's a strange experiment in quantum physics called the principle of least action. It's one of the most hauntingly elegant rules in all of science. It says that a particle, or a beam of light, will always take the path that requires the least effort, the simplest route from one point to another. Not necessarily the shortest in distance, but the one that minimizes energy. But here's where it gets beautifully disturbing. To take the most efficient path, the particle must first consider all possible paths, every angle, every curve, every failed trajectory, every impossible detour. In a sense, it must explore the entire landscape of reality, every route the universe permits, before selecting the one that fulfills this strange, silent logic of efficiency. That's what gives us this paradox. Light, that took the longest shortcut. Because sometimes, in complex systems, when light moves from one medium to another, like air to water, it bends, slows, twists. It takes a path that seems absurd at first glance, a curve instead of a line, a delay instead of a dash. Yet when we do the math, we find that the curved path was, in fact, the most efficient. The shortcut was longer, and it had to be. In physics, this is called Fermats Principle, but it's more than geometry. It's a cosmic suggestion, one that applies to more than photons. It applies to you. How many times have you thought, this isn't the quickest way, or this is taking too long, or I should have been there by now. We treat our lives like we treat light, always racing, always aiming for the straightest possible line between where we are and where we think we should be. But what if the curve, the mistake, the delay, the heartbreak, the uncertainty was the most efficient route? Not for speed, but for transformation. What if the longer path is the only one that makes you ready? Light doesn't question the curve. It doesn't doubt the delay. It just obeys the hidden structure of the universe and bends when it must, and maybe so should you. Light that took the longest shortcut is about surrendering the illusion of the straight path. It's about trusting that the longer arc may still be the shortest way to where you're truly meant to go. Think about the people you've met because of a detour, the lessons you learned when things didn't go as planned, the growth that happened, not in victory, but in the waiting. In physics, that bend in the light is called refraction. In life, we call it becoming. There's something deeply humbling about this idea that even light, perfect and constant, has to explore every possible route before finding its way, and it does it instantly, in silence, without needing permission. The beam of light doesn't resist the curve. It honors it. It listens to the structure of space. It hears the shape of the world, and so must you. You don't need to know why the path is winding. You don't need to see the destination to keep moving. You only need to trust the strange law written into the heart of all things, that sometimes the quickest way out is the way through, that sometimes the path that seems inefficient is the one that saves you, that sometimes the universe slows you down, not to punish you, but to prepare you, because shortcuts are not always straight, and light, in all its perfection, bends for a reason. You've always known that to move something, you must touch it. You push a door, and it opens. You press a key, and a sound is made. Contact equals cause. Action requires contact. That's how the world works. Or so you thought, because then came a force, unseen, untouched, and it moved everything without ever laying a hand. Force that pushed without touching. From childhood, we're taught the Newtonian view. Force equals mass. Times acceleration. You shove a box, it slides. You pull a rope, it tugs back. It's all mechanical, all intuitive, but not everything in nature obeys this tactile logic. Consider magnetism. Place two magnets near each other, and they either snap together or repel apart, despite no contact. There's no visible medium, no string, no pushing hand, yet the motion is real. Now scale that up to the universe. The moon doesn't touch the Earth, but it pulls our oceans. The sun doesn't touch the Earth, yet it holds our planet in orbit. These interactions, gravity, electromagnetism, the nuclear forces, shape everything, yet occur across empty space. Welcome to the paradox of the force that pushed without touching. It challenges the most basic assumption we carry. That interaction requires nearness. It doesn't. The universe is held together by invisible whispers, fields, waves, curvatures in space-time that reach across nothingness and still manage to bind, to shape, to control. And yet, this isn't just about physics. This paradox lives in you too. Have you ever walked into a room and felt the atmosphere change without a word spoken? Felt someone's presence behind you before you turned around? Been affected by a decision you didn't witness, a memory you didn't create, a love or trauma that wasn't yours? Then you felt a force that pushed without touching. Human lives are bound together by unseen influences, words unspoken, glances stolen, generational trauma passed down not through DNA, but through posture, silence, expectation. You were pushed by things that never touched you, just like the planets, just like the stars. Science explains it through fields, regions of influence, the electromagnetic field, the gravitational field. Every particle, every point in space carries a hidden web of potential, a reach that exceeds its size, a presence that stretches beyond its body. So what is your field? What energies ripple out from you, unseen, yet felt? Perhaps your intentions matter more than your actions. Perhaps your silence speaks louder than your voice. Perhaps the gravity of your pain or your hope pulls others into orbits you'll never see. Force that pushed without touching is a reminder that not all impact is visible. Not all motion has a hand behind it, and not all influence is earned through effort. It is the unseen that shapes the seen, the field that defines the force. Even Einstein struggled with this. He called quantum entanglement spooky action at a distance, two particles separated by light years, somehow affecting one another instantly. As if touch no longer mattered, as if space itself had no say. But maybe that's not spooky. Maybe it's sacred. Maybe distance is an illusion, one we invent to feel separate from what we're already connected to. Because here's the truth. You don't need to be close to someone to change them. You don't need to touch someone to hurt them or heal them. We are fields overlapping. We are gravitational wells of memory, pain, joy, and longing. We collide without contact. We change each other in the silence. So the next time you feel small, remember the force that moves the stars, the force that pushes planets without ever touching them, the force that turns silence into motion, distance into connection, nothingness into gravity. And know that you too are made of this. You push, even when you don't know it, even when no one sees it, even when there's no contact at all. You've looked at the stars before, countless, distant, unreachable. You felt the vastness of the universe stretching beyond your comprehension. Light years, galaxies, endless time. And still, none of it prepared you for this. That something truly infinite could be compressed into a single fleeting thought. Infinity that fit inside a thought. Infinity is supposed to be too much, too large, too long, too eternal. It's the idea that no matter how far you go, there's more. A number that never ends. A staircase without a top. A road that loops forever. In mathematics, we accept infinity as a concept, but it's never a number we can use. You can approach it, approximate it, even build equations around it, but you can't grasp it. It's always just out of reach. But in your mind, it shows up without warning. Have you ever replayed a single moment of heartbreak on a loop so endless it felt eternal? Have you ever imagined an entire lifetime, choices, regrets, possibilities, within seconds of silence? You've tasted infinity, and you've done it inside your head. That's the paradox of infinity that fit inside a thought. That your limited, biological brain, bounded by neurons and blood and bone, can contain something the universe itself struggles to hold. Science tells us that the brain is made up of roughly 86 billion neurons. These neurons can form trillions of connections, firing signals in intricate webs of logic, memory, and emotion. The combinations are not just large, they're functionally infinite. A single second of your inner world could host universes. Thoughts nested within thoughts. Dreams that fold time. simulations of futures that will never happen, yet feel more real than the present. Your consciousness is a hologram of infinities, not because it understands the universe, but because it mirrors its shape. In physics, some infinities break the rules. They show up in equations where they shouldn't, like in the center of a black hole, where mass becomes infinite and the laws of physics collapse. Or in the quantum vacuum, where fluctuations are endless. These infinities aren't just big, they're dangerous. They signal a boundary, a point where our understanding fails. So what does it mean that your mind can hold one? Is it proof of depth, or a warning of collapse? The human mind is not built for endlessness, and yet it cannot stop reaching for it. Every story we tell has echoes of the infinite, love that lasts forever, revenge without end, a God who sees all, time at once. And what's more shocking, our minds can't just contain these ideas. They generate them endlessly. You think a thought, that thought leads to another, then another, and another, until you're somewhere else entirely. The recursion is bottomless. You are not just thinking, you are spiraling. That's infinity, not as a number, but as an experience, infinity, that fit inside. A thought challenges the idea that reality is defined by what is physically large. It asks you to consider that perhaps the infinite isn't out there among the stars, but in here, behind your eyes. And, if that's true, then what are you? A vessel for boundlessness, a simulation engine, constructing eternity one thought at a time. Some theories in neuroscience propose that consciousness itself may arise from quantum processes, microtubules in the brain functioning at a subatomic level. If even a grain of that is true, then your awareness may be entangled with infinities, deeper than space. You are not small because your body is small. You are not limited because your life is short. You are infinite in a way the stars are not, because they burn. They shine, then they die. But you imagine. You imagine things that have never existed. You build infinities with no materials. You carry endless versions of yourself in silence. That is not a flaw. That is your power. So the next time your thoughts spiral, don't fight it. Follow them. Trace the fractals. See where they lead, because somewhere in that dizzying, boundless recursion, you might find that the infinite you've been searching for in the sky was always hidden in the space between your thoughts. You were told that emptiness is the absence of everything, that a vacuum, by definition, is void, no matter, no energy, just blankness. But what if the most silent spaces are hiding the loudest truths? What if the vacuum is not empty at all, but alive, vacuum, that was never empty? For centuries, we thought of space as a backdrop, a cold, passive container where things happened. Stars burned, planets spun, comets flew, and in between, just nothing. Then quantum mechanics arrived, and it shattered that illusion. In the quantum world, even a perfect vacuum, a region stripped of all matter and radiation, is not empty. Instead, it roils with energy. Virtual particles blink in and out of existence, borrowing time from nothingness and then vanishing before the universe notices. This phenomenon is called quantum vacuum fluctuations, and it's not hypothetical. It's real. It's measurable. In 1948, the Casimir effect proved it. Two metal plates placed in a vacuum will move toward each other without any force applied. Why? Because the energy of the vacuum itself changes between them. There's more fluctuation outside than inside, and the imbalance causes a push. Think about that. Two objects, No contact, no field, just empty space, and it moves them. This is the paradox of the vacuum that was never empty, because the thing you assumed was the most nothing is actually something, seething, breathing, whispering. This isn't just a fun physics trick. It rewrites how we understand the fabric of reality. It tells us that nothing is not the absence of being, but the foundation of it. The canvas isn't blank, it's buzzing with potential. Every atom that ever existed was born from this trembling stillness. Every particle, every galaxy, every thought emerged not from fullness, but from emptiness. So what does that say about you? How often do you fear the void, the silence, the in-between moments where nothing seems to happen? You call them empty. You think they are wasted. You rush to fill them. But maybe they are the most fertile moments of all. Maybe your own vacuum states, those seasons of loss, stillness, doubt, are the moments where reality trembles beneath the surface, where the next version of you is waiting to emerge, unobserved but inevitable. In the vacuum of your identity, perhaps there are still particles flickering, possibilities dancing in silence, versions of you rehearsing their birth. The vacuum that was never empty reminds you that stillness is not stagnation. It is pressure, potential, the stage before emergence. Even in outer space, vast and cold, the vacuum is not dead. It has a pressure, a tension, a structure, the cosmological constant which accelerates the expansion of the universe may arise from this vacuum energy. In other words, the emptiness of space is driving everything apart. The nothing is what's making everything happen, and perhaps that's the final truth we're meant to swallow. That silence is the loudest sound. That stillness is the most powerful motion. That the things we think are absence are actually presence, waiting to be seen. You were taught to fear the void, to avoid it, to resist the ache of being alone with nothing. But maybe the void is not your enemy. Maybe it's your origin and your answer. So the next time you find yourself in a moment that feels hollow, remember the vacuum. It looks empty, but it's the most creative force in the universe. And inside you, there is no such thing as nothing. Only the waiting hum of the next great becoming. We grow up believing in straight lines. Roads go forward, time moves ahead. Dimensions stretch outward. Progress is linear. But what happens when the line folds? What happens when space itself turns inward? Because not every path leads away. Some paths lead back, and some dimensions don't open. They collapse. Dimension that curved into itself in Einstein's theory of general relativity, space isn't a flat stage where events unfold. It's a dynamic fabric, one that bends, stretches, and curves in response to mass and energy. Gravity isn't a force pulling objects together. It's the warping of space-time itself. The more mass something has, the more it dents the fabric. Imagine placing a bowling ball on a trampoline. Everything nearby rolls toward it, not because the ball is reaching out, but because the surface has curved. Now imagine this curving going further. So far that space stops being a surface and becomes a spiral. In some extreme cases, like inside black holes or at the edges of high-energy events, space-time doesn't just bend, it loops, it closes, it curves inward to a point where the idea of direction breaks down entirely. That's the paradox of the dimension that curved into itself. Because we think of dimensions as extending, length, width, height, time, even theoretical higher dimensions. They are supposed to open more possibilities, give more room to move. But what if a dimension didn't expand your options? What if it reduced them? What if movement forward simply brought you back to where you started? This isn't just an idea, it's embedded in modern physics. Some theories of the universe, like compactified dimensions in string theory, suggest that certain dimensions are not wide open, but tightly curled. So tight, in fact, that you can move through them infinitely and never seem to go anywhere. They are loops, invisible to us, but real, and they may hold the secrets to everything. So what does that mean? For space, for time, for you? It means you may be living inside a reality where progress is an illusion, where your every step forward echoes one already taken, where the boundary between past and future, between out and in, is a folded line. Think about how your life behaves when it spirals, how you repeat patterns, how you date the same kind of person, make the same mistakes, return to the same doubts, even when you thought you'd left them behind. You assume you're failing, but maybe you're simply moving along a curved dimension. 1. That brings you back to the start, not to punish you, but to show you something you missed the first time around. The dimension that curved into itself is a warning against the worship of straight lines. It dares you to question the idea that more space equals more freedom. Because maybe freedom isn't about movement. Maybe it's about awareness inside the loop. And here's the deeper truth. If a dimension can curve into itself, then location becomes a lie. Then place is not fixed. Then you are not fixed. In mathematics, topology explores spaces like this. Surfaces that bend and fold in impossible ways. A Mobius strip. A Klein bottle. A torus. Objects that defy inside and outside, beginning and end. Maybe your consciousness is a space like that. Maybe your soul is not a line, but a fold, a recursive loop, a map you redraw every time you return. And maybe you haven't gone backwards at all. You've just curved. Let this paradox change. You do not need to keep fleeing your past. It is not chasing you. You're just orbiting it until you understand it. And then the loop might open. Because not every dimension frees you by expanding. Some only free you once you realize they were never meant to be escaped. They were meant to be seen, understood, integrated. The line isn't broken, it's curved, and it curves for a reason. You make choices every day believing they matter, believing that your decision slices through possibility and makes something real, that the other options fall away, that the universe responds. But what if they don't? What if every probability you tried to bury never actually died? Probability that refused to collapse at the quantum level. Reality isn't fixed. It's fuzzy. A particle exists in a superposition. Multiple states at once. It's here and there. It spins up and down. It moves left and right. Until, supposedly, you measure it. Until your observation collapses the probabilities into a single reality. This idea, the collapse of the wave function, has shaped quantum theory for decades. But some physicists have a problem with it. They ask, collapse to what and why? If the universe is governed by pure mathematics and probability, why would it suddenly arbitrarily snap to a fixed state just because someone looked? And so another interpretation emerged. One that breaks the mind. It says, maybe the probability never collapses. Maybe every possible outcome happens not in metaphor. In fact, this is the many worlds interpretation of quantum mechanics. It proposes that with every quantum event, the universe splits. One version branches off where the cat lives, another where it dies. One where the electron is here, another where it's there. All probabilities continue to exist. All possibilities are real. Nothing ever dies. Nothing ever collapses. This is the paradox of the probability that refused to collapse. It challenges our most basic sense of cause and effect. You flip the coin, it landed heads, but in another version of reality, it landed tails, and both outcomes exist permanently. Now step back. Think about the choices you didn't make, the people you didn't become, the paths you walked away from. According to this interpretation, none of them are gone. They're just elsewhere, living out in full inside a universe you'll never see. The probability didn't collapse. It branched, and you are simply one leaf on an endlessly splitting tree. This isn't fantasy. It's an attempt to make quantum mechanics consistent without magic. No collapsing, no special observer, just infinite, branching math. Cold, logical, eternal. But what does it mean? For you, it means your regrets are still alive. It means your alternate selves exist, laughing, grieving, evolving in parallel timelines. It means every decision you make doesn't erase the other options. It simply chooses which you will follow them. That's both horrifying and liberating, because if the probability that refused to collapse is real, then nothing is ever truly lost. Not your childhood dreams, not the words you never said, not the version of you who never gave up. They're all still out there, on different branches, moving forward without you, but still, you. And now here's the twist. If all possibilities remain real, then your current reality isn't privileged. It isn't the true one. It's just one thread, one version, one line in a vast cosmic web. So what does that mean for your meaning, your purpose, your sense of who you are? It means you are less a fixed identity and more a process of selection, a narrowing of infinite potential into one conscious stream, and maybe, just maybe, when you feel the ghost of a life unlived, when you hear the echo of something that never happened, you're not imagining it. You're brushing up against another branch, another probability that never collapsed. So how do you live in a world like this? You stop looking for finality. You stop craving closure. You stop pretending that one version of you is the only one that matters, and you start honoring the mystery that inside every choice is a doorway to all choices, that inside every moment is an infinite fracture, that the universe is not collapsing into simplicity, it's expanding into complexity. And the version of you reading this, the one aware of the paradox, that awareness is not an end, it's a beginning. Because in the quantum world, to observe is not to collapse, it's to entangle. And now you're entangled with the truth. You were told that black holes are destroyers, cosmic vacuums that swallow light, matter, time, leaving behind nothing but silence. You were told that what goes in never comes out. But that was a lie. Because the universe remembers everything. Even the darkest places leave fingerprints. Black hole with a memory. At the center of most galaxies, including our own, lies a supermassive black hole, millions or billions of times heavier than our sun. These beasts are not just massive, they're invisible. A black hole's gravity is so intense, not even light escapes. Once something crosses the event horizon, it's lost, erased from the observable universe. Or so we thought. The old belief was simple. Black holes devour information. Throw in a book, a person, a planet. It doesn't matter. Whatever complexity or structure they had is gone. All that remains is mass, charge, and spin. The rest, vaporized. But this idea caused a problem, because in physics, information must be conserved. According to quantum mechanics, the universe doesn't delete data. Every atom, every wave function, every interaction, no matter how chaotic, retains information about its origin. If black holes erase that, then quantum theory breaks. And if quantum theory breaks, the entire foundation of modern physics begins to rot. So began the most infamous puzzle in science, the black hole information paradox. Stephen Hawking himself proposed that black holes radiate energy, what we now call Hawking radiation, and eventually evaporate. But if a black hole disappears, and the information about what it swallowed goes with it, that's a crime against quantum law. Then came the twist. Newer theories suggest that black holes do not forget, they remember. Not with clarity, not with perfect recall, but in a scrambled, encrypted form, like a cosmic safe full of shredded pages. The pieces are still there, but no one knows how to read them. Some physicists believe that information is stored in the event horizon itself, holographically encoded on its surface, a memory etched into the very edge of space-time. Others think Hawking radiation may carry that information out, one photon at a time, like whispers from the void. So now we arrive at the paradox of the black hole with a memory, that the place we once thought was the ultimate eraser may be the universe's most secretive archivist. Think about that in human terms. How many parts of yourself have you tried to destroy? How many memories have you buried so deep you thought they were gone? How much pain have you thrown into your own black hole, hoping it would disappear? But maybe your internal void remembers. Maybe nothing inside you is ever truly lost. Not the things you said, not the people you hurt, not the versions of you that died along the way. They're not gone. They're encrypted. You are a black hole with a memory, and maybe, like the universe, you are radiating the past in subtle ways, without realizing it, through body language, through instinct, through the way your voice catches when you speak certain names, through the dreams you can't explain. The information is still there, just hidden. And here's the terrifying beauty of it. Even if you can't decode it, it's shaping you. Just like a black hole's past shapes its radiation, your unspoken truths ripple through your present. You emit echoes. You shine, even in darkness. Physics may never fully resolve the black hole information paradox. Maybe the answer lies in some future theory of quantum gravity. Maybe it's encoded in string theory or loop quantum gravity. Or maybe the paradox is the answer, that remembering and forgetting are not opposites, but entangled. That even in total collapse, somehow, the story survives. So the next time you feel like a part of you has vanished, like your past has been swallowed, remember this. Not even a black hole gets to forget, and neither do you. You don't need to retrieve it all. You only need to honor the possibility that nothing was ever wasted, that every part of you, even the parts you tried to erase, still lives somewhere in your field. Maybe healing doesn't mean forgetting. Maybe it means decoding. And maybe, just maybe, the deepest part of you isn't the light you show, but the darkness that remembers everything. In science, constants are sacred. They're the numbers that anchor the universe, the speed of light, the gravitational pull, the fine structure constant, unchanging, reliable, absolute. But what if one of those unshakable truths wasn't so? Constant after all. Constant that changed every time it was measured. Imagine trying to build a bridge, only every time you measured the length of a meter, it was different. Or designing a spaceship, only to discover that gravity isn't what it was last Tuesday. That's chaos, that's absurdity, that's the collapse of science. Yet this is exactly what some physicists have begun to suspect. That certain constants, numbers we believe to be written into the code of existence, may not be fixed. They may shift, silently, subtly, just beyond the edge of certainty. The most famous suspect, the fine structure constant, denoted as A, alpha. It governs how light interacts with matter, how atoms hold together, how photons behave. If alpha changed by even a fraction, the entire structure of atoms would collapse. Stars would fail, life would vanish. And yet, deep space observations suggest that in certain regions of the universe, alpha might be ever so slightly different. Some spectroscopic studies, looking at the light from ancient quasars, have found minute variations in this constant across billions of light years. Not enough to destroy reality, but enough to rattle the illusion of stability. Hence the paradox of the constant that changed every time it was measured. Because if something as fundamental as alpha can shift, what else might be in flux? And if constants aren't truly constant, then what can we actually trust? Now bring that idea home. Think about your own constants, your identity, your beliefs, the core rules you thought would never change. I'll never betray someone. I'll always know who I am. I could never forgive them. I'll always believe in this. And yet, hasn't life quietly adjusted those constants? Under grief, under growth, under pressure. You've said things you swore you never would. You've believed new truths. You've bent in ways you thought impossible. The constants of your character, once so rigid, shifted with time, not violently, but imperceptibly, like light bending through space. And isn't that what makes you human? We like to think of ourselves as fixed. We anchor our identity to absolutes. But the truth is more fluid. You're not made of laws, you're made of fluctuations, just like the universe. And here's the deeper danger. If our constants are unstable, how do we know which version of reality we're living in? What if science isn't discovering eternal laws, but local rules, temporary snapshots of a larger, evolving system? In string theory and multiverse models, different universes could operate under entirely different constants. Gravity could be stronger, time could move differently, the speed of light could vary. What feels like a law here may be a fluke somewhere else. Maybe constants aren't constants, they're agreements, held in place by context, by consensus. And maybe you're the same. Maybe you are not a singular, permanent self, but a shifting set of rules that adjust depending on where, when, and who you are. The constant that changed, every time it was measured, is more than a scientific glitch. It's a warning that what you take for granted may be in motion, that the floor beneath your thoughts is moving, that the ground under your feet is a negotiation. So what do you hold? Onto? Not permanence, not control, but awareness. The ability to notice when the rules change, the courage to adapt when they do, the humility to accept that even your most sacred truths may evolve. Because maybe the constants aren't failing. Maybe they're whispering, keep looking, keep asking, nothing is as stable as you think, and that's exactly why it works. It was supposed to be a shortcut, a tunnel through time, a bridge across space, a way to cheat the rules that kept us small, slow, and stuck. But when they reached the other side, they found nothing. Because not every portal leads somewhere, some just lead back. Wormhole that went nowhere. Wormholes are among the most tantalizing possibilities in physics. Theoretically permitted by Einstein's equations, they represent a tunnel through the fabric of space-time, connecting two distant points in the universe, or even two moments in time. A cosmic loophole, a fold in the map. The concept itself isn't science fiction. Mathematically, wormholes are real solutions to the equations of general relativity. We call them Einstein-Rosen bridges. But here's the catch. Just because the math permits, it doesn't mean the universe does. Wormholes, if they exist, would be unstable. They'd collapse almost instantly unless held open by some form of exotic matter, a substance with negative energy. And we don't know if such matter exists in a usable form. We don't know if these bridges are even crossable. We don't know if they'd lead somewhere new or somewhere horrifyingly familiar. That brings us to the paradox of the wormhole that went nowhere. What if you stepped through the tunnel expecting a different galaxy, a different time, but ended up right where you started? Or worse, inside, a loop you can never escape. In some solutions, wormholes curve back into themselves, creating closed time-like curves. You could travel through them endlessly, experiencing the illusion of movement, of progress, of change, only to realize you've never actually left. Now take that metaphor into your life. How many of your solutions have just led you in circles? How many escape plans brought you back to the same pain? How many times have you felt like you were breaking free, only to discover that freedom was just a new version of the same trap? That's the emotional reality of the wormhole that went nowhere. Sometimes you don't need a new destination. You need a new map, because movement without direction is just orbit, and not every tunnel leads to light. Physicist Kip Thorne explored the idea of wormholes as time machines, portals into the past the math holds. But then we run into paradoxes. If you go back in time and change something, do you erase yourself? Do you cause the thing you're trying to prevent? Does your arrival create the very conditions that forced you to leave? It's the snake eating its tail. Causality turned inward. A story with no beginning, because every ending becomes its origin. Now, ask yourself, what if your mind contains its own wormholes? Tunnels built from trauma, regret, nostalgia, obsession. Pathways that loop your thoughts into spirals. You believe you're healing, but you're just rephrasing the wound. You think you're remembering, but you're only rewriting. You feel progress, but you're walking the same emotional corridor again and again. You're in a wormhole, one that goes nowhere, and yet, maybe that's not failure. Maybe that's a message that not all shortcuts are meant to be taken. That some structures exist not to transport you, but to trap you until you understand, until you stop moving. And see, because the solution isn't always forward. Sometimes it's stillness, reflection, the choice not to step through the next glowing door. The wormhole that went nowhere is a warning that not all opportunities are what they seem, that not every portal opens to a new world, and that the deepest journeys sometimes happen without distance. So the next time life offers you an escape, ask, is this a passage or a pattern? Will it deliver you or just disguise the return? Because some wormholes look like miracles until you realize you've been here before. You were taught that the world exists outside of you, that it's solid, independent, objective, that your eyes merely report what is already there. But quantum physics has a different story to tell. One where the act of observing doesn't just Reveal reality. It creates it. Observer that created its own reality. In the classical view of physics, the world functions whether or not anyone is watching. A tree falls in the forest and it makes a sound. A rock spins in space, indifferent to your gaze. Reality is self-contained, impartial. But in the quantum world, things aren't so passive. Particles don't have fixed positions, speeds, or identities until they're measured. Until someone looks. The infamous double-slit experiment showed this in eerie detail. When electrons are fired through two slits, they create an interference pattern, like waves. This suggests each particle acts like a wave, passing through both slits at once. But if you observe which slit the electron passes through, the interference disappears. The electron behaves like a particle. The wave collapses. The very act of observation changes the outcome, and not just in metaphor, literally. This leads to the unsettling idea that the observer and the observed are entangled, that your consciousness isn't just witnessing the universe, it's shaping it. Hence the paradox of the observer that created its own reality. Because if particles behave differently under observation, then reality is not independent of the mind. It's participatory. This doesn't mean you can bend spoons with your thoughts or manifest a mansion with intention. But it does mean that the boundary between perception and truth is thinner than we ever imagined. So what are you really seeing when you look at the world? An objective reality or a reflection of your expectations? In psychology, this mirrors the concept of confirmation bias. You find what you expect to find. Your beliefs filter your perception. Your brain deletes information that doesn't fit your worldview. You don't see things as they are. You see them as you are. You observe. You collapse the wave. You define the world. Even your identity is subject to this loop. You think, I'm this kind of person, and so you notice evidence that supports that. You reject the rest. Over time, your narrative becomes your reality, not because it was always true, but because you observed it into being. And maybe that's what this paradox is trying to tell you, that you are not just living in a reality, you are generating one. In modern interpretations like Cubism, quantum Bayesianism, the wave function is not a property of the system itself, but of the observer's knowledge about the system. Reality isn't a fixed state, it's a probability, field, collapsing in response to your inquiry. So what happens when you stop looking? What happens when no one's watching? Does the world continue as it was? Or does it hang, suspended in possibility, waiting for the next observer to cast their gaze? If reality is shaped by the observer, then nothing is neutral. Your presence matters. Your attention matters. Where you look determines what becomes real. And where you refuse to look allows illusion to persist. This should terrify you and empower you, because it means the stories you keep telling yourself, the ones about who you are, what you deserve, what you're capable of, aren't passive beliefs. They're blueprints. They're instruments collapsing the wave. You are a quantum agent, a builder of worlds. And here's the catch, so is everyone else. We're all collapsing different parts of reality all the time, overlapping, interfering, shaping a collective hallucination we call the world. Your reality isn't just personal, it's entangled with everyone else's. And that makes this paradox not just about science, but about responsibility. Because if you're helping to shape reality, even in the smallest, quietest ways, then what are you choosing to observe? What truths are you choosing to reinforce? What lies are you refusing to collapse? The observer that created its own reality is not a myth. It's a mirror, and it's asking you one question. If you are the observer, then what kind of reality are you creating? You think mass is solid, heavy, permanent. You can touch it, weigh it, measure it. You believe something either exists or it doesn't. That matter is a fixed quantity. But in the strange fabric of the universe, even mass can vanish. Not with a bang, but with a glance uncast. Mass that disappeared when you weren't looking. In the classical world, mass is an anchor. It keeps objects grounded, predictable. An apple has mass, so it falls. A boulder has mass, so it resists being moved. You never question it. Mass is mass. But quantum mechanics doesn't play by classical rules. On the quantum scale, particles like electrons don't have definite positions or definite mass until they're observed. They exist in superpositions, clouds of probabilities, waiting to collapse into reality. Until then, their properties are undefined, unreal, suspended in a ghostly limbo. This is especially true in fields like quantum chromodynamics, where particles like quarks and gluons behave according to shifting energy states. Their mass isn't fixed. It fluctuates based on interactions. Even virtual particles, those that spontaneously emerge and vanish from the vacuum, briefly borrow mass and energy from nowhere, only to disappear before violating conservation laws. In these cases, mass is not a permanent trait, it's a performance, and the stage lights are your observation. That's the paradox of the mass that disappeared when you weren't looking. It reveals that what you think is real may be entirely dependent on attention, that the universe doesn't finalize details until someone asks a question. That matter itself may be more conditional than we ever imagined. Now zoom out. Take this idea into your everyday life. What else begins to vanish the moment you stop looking? Friendships, memories, parts of yourself? We often think that once something is known, it stays known. Once something is real, it stays real. But that's not always true. Neglect can unmake reality. Leave a house abandoned and it crumbles. Stop watering a plant and it dies. Ignore someone you love long enough and they become a stranger. You assumed permanence, but permanence is an illusion. Even your identity is a superposition of expectations, roles, and reflections. You are not one fixed thing. You are what people project onto you, what you reflect back, what you reinforce. And when those projections disappear when no one's watching, you begin to blur. Mass is not the only thing that disappears when ignored. So does meaning. The mass that disappeared when you weren't looking is a metaphor for everything you take for granted. The people, the possibilities, the parts of you waiting for attention. In physics, the Higgs field is what gives particles their mass. It's an invisible field permeating space, and particles that interact with it gain weight, literally. Without it, there would be no atoms, no chemistry, no you. But here's what's wild. The Higgs field doesn't turn on when you look. It's always there, just like the parts of you that remain unacknowledged. But unless you interact with them, they remain inert, massless, weightless. So ask yourself, what part of you is vanishing while you're not paying attention? What inner mass have you ignored into non-existence? Maybe your curiosity, your creativity, your grief, your joy, all of it waiting to become real again. All of it needing only one thing, your gaze. Because attention is not just focus, it's permission. It tells the universe, this matters now, and the universe listens. So the next time something feels like it's slipping away, ask if you've stopped looking. Ask if it's still there, waiting to be collapsed back into presence. Because not all disappearances are permanent. Some things are reversible if you remember to see them. The mass that disappeared when you weren't looking isn't just a paradox of physics. It's a philosophy of care. To observe is to affirm. To ignore is to erase. And reality is always watching. You watch it. You expect time to behave, to move forward, to obey cause and effect. The past pushes into the present. The present pushes into the future. But what if something arrived before it ever began? Photon that left before it arrived. In everyday life, causality is law. You press the brake, then the car slows. You light a match, then the fire ignites. The cause comes before the effect, always. But at the quantum level, the universe plays a different game. A game where effects sometimes seem to appear before their causes. Where light may act as if it knew what was going to happen before it did. One of the most haunting examples of this is the delayed choice quantum eraser experiment. Building on the classic double-slit setup, this experiment adds a twist. The decision of whether or not to observe a particle is made after it has already passed through the slits, and somehow, impossibly, the particle's past behavior seems to depend on that future decision. The interference pattern, where light behaves like a wave going through both slits, only appears if we choose not to measure which path the photon took. If we do measure it, the interference vanishes. But here's the kicker. This choice is made after the photon has already hit the screen. It's as if the photon waited, retroactively adjusting its history based on your later decision. Welcome to the paradox of the photon that left before it arrived. It breaks the idea of linear time. It breaks the idea that the present is untouched by the future. It breaks your sense of cause itself. Now, does this mean photons literally travel backward through time? Not quite. What it suggests is that the universe doesn't finalize the script until the last page is turned. That reality is not a sequence, but a totality, interconnected in ways our logic cannot follow. That past and future may be more like perspectives than fixed stages. Let that rearrange you for a moment. How often do you think of your past as complete, sealed off, done? You believe that your childhood, your decisions, your mistakes are etched in stone, but maybe they're not. Maybe your present choices are quietly reshaping the way your past exists within you. Maybe the story you tell today is bending the photon that you were. Have you ever remembered something differently years later? Have you ever reinterpreted an event after learning a new truth? Then you've already lived this paradox. You've been the photon. You've left, and then rewritten your departure. You've adjusted your history to match the meaning that came later. This isn't delusion. It's a feature of consciousness. Memory is not a filing cabinet. It's a living system. It evolves as you do. Your perception of the past is shaped by your present understanding, and your future will reach back and change this moment again. The photon that left before it arrived reminds you that time may not be a river flowing forward, but a sea you swim in, all at once. In physics, this is part of the block universe theory, the idea that past, present and future all coexist, that your life isn't unfolding moment by moment, but existing as a whole tapestry, already woven. You only experience it linearly because that's how your consciousness is wired to move through it. So what happens if you slow down? What happens if you begin to feel time differently, not as a straight line, but a field? You might realize something staggering, that you are not after your past. You are still in it, just looking at it from a new angle. And you are already inside your future too. The photon didn't break time. It revealed that time was never straight to begin with. So when you feel stuck in the past, ask what future choice is waiting to rewrite it. When you feel uncertain about tomorrow, ask what unprocessed memory is still shaping it. Reality is not finished. Your story is not sealed. The photon that left before it arrived teaches us that the universe is recursive, relational, and alive. And you are a traveler, not of time, but of awareness. They say time moves forward because of entropy, that the universe trends from order to disorder. Ice melts, structures collapse, stars burn out. But what if one day, everything started moving in reverse, quietly, invisibly, without warning, not with noise, but with silence? Entropy, that reversed in silence in thermodynamics. Entropy is the measure of disorder. The more disordered a system becomes, the higher its entropy. And according to the second law of thermodynamics, entropy always increases over time in a closed system. It's the arrow of time. The reason why we remember the past, but not the future. Why eggs don't uncrack. Why broken things stay broken. Entropy gives time its direction. But what if that arrow isn't absolute? In certain rare quantum systems, scientists have observed behavior that seems to defy entropy's flow. In small isolated systems, entropy can momentarily decrease. Not by magic, but because quantum systems don't operate like classical ones. Their rules are probabilistic, not deterministic. In these tiny systems, randomness can briefly reverse the trend of disorder. Imagine a puzzle that reassembles itself, just once, just briefly, before chaos returns. This isn't just a thought experiment. In 2019, researchers used a quantum computer to reverse the arrow of time for a single electron-like system. It was artificial, controlled, and limited, yet real. Entropy moved backward. The system became more ordered, not with fire, not with force, but with calculation, with stillness. Hence, the paradox of the entropy that reversed in silence. Because if time's direction depends on entropy, and entropy can be reversed, then what exactly is holding time together? And more unsettling, what happens if this reversal occurs on a larger scale? What if, right now, something is unbreaking? What if time is folding inward in a corner of the cosmos, and we haven't noticed because it's happening without a sound? Let's bring it home. Think about your life as a system of entropy. Over time, things fall apart. Relationships fade. Bodies age. Emotions fray. You accumulate clutter, externally and internally. You call it growing up or breaking down. You assume the chaos is inevitable. But what if some part of you was quietly moving the other way? What if healing doesn't announce itself? What if becoming whole again happens in stillness, beneath your awareness? Think of those mornings where something inside you feels lighter, but you can't explain why. The day you forget to grieve, the moment you no longer react the way you used to. Entropy reversed, not in fire, but in silence. We're obsessed with noise, big events, dramatic change, explosive healing. But the entropy that reversed in silence reminds us that not all transformation is loud. Some of it is molecular, subtle, recursive, slow, like atoms reassembling behind your back, like a mind finding peace without permission. There's a concept in physics called negentropy, the reversal of entropy. It's rare, local, and fragile. Life itself is often described as a negentropic force. We build structure. We resist decay. A baby grows from a cell. A mind forms from neurons. An idea takes shape in a thought. Every time you create, you reverse entropy. Every time you forgive, you reverse entropy. Every time you remember your worth after forgetting, you reverse entropy, and you do it quietly. Because maybe silence isn't the absence of motion. Maybe it's the sound of order returning, of time, remembering how to heal. So the next time you feel like everything's falling apart, pause. Listen. You might catch the faint rhythm of something reassembling. Entropy doesn't mean hopelessness. It means context, and context can change. The entropy that reversed in silence isn't just about physics. It's about faith. The belief that even when everything looks like it's breaking, something deeper might be quietly putting itself back together. And when you finally notice it, it won't be with fireworks. It'll be with breath, with calm, with the quiet hum of wholeness returning. You touch the table and it feels firm. You stand on the ground and it feels certain. Your body, your home, the world. Everything seems stable, material, real. But beneath it all is a truth so strange it defies your senses. Nothing you've ever touched was truly solid. It was all just a field, dreaming. Quantum field, that dreamed it was solid. In modern physics, matter isn't made of tiny hard balls orbiting like miniature planets. That's a relic of old models. The deeper we dig, the more surreal the truth becomes. At the fundamental level, everything is made of quantum fields, continuous, invisible energy fields that stretch across the universe. Electrons, photons, quarks. They are not standalone particles. They are excitations in these fields, ripples, vibrations. A particle is what a field looks like when it shivers in just the right way. This is the foundation of quantum field theory, QFT, the most accurate and tested framework in all of physics. According to QFT, there are no particles in the traditional sense. Only waves, only pulses, only patterns in an otherwise invisible ocean of possibility. You are not made of solid matter. You are made of organized fluctuations. The paradox of the quantum field that dreamed it was solid is that the entire material world, chairs, mountains, flesh, steel, only appears firm because your perception is tuned to a narrow bandwidth. You interpret these ripples as shape, weight, and boundary. But those are illusions of scale, of interpretation. Zoom in far enough, and the solidity vanishes. Atoms are 99.99999% empty space. The rest, probabilities, ghosts of presence. Nothing is really there, just the potential to be. So why does it feel so real? Because your senses are built for survival, not truth. Your brain constructs solidity to help you navigate. It renders a model of the world, much like a computer renders a 3D image. Fast, convincing, useful, but not real. And if the world is built on fields, then so are you. Your thoughts? Fluctuations in neural fields. Your emotions? Chemical fields surging through the body. Your identity? A stable pattern echoing through years of organized noise. Even yourself is a ripple in a larger wave. So what does it mean when a field dreams it's solid? It means we're living in a universe that pretends to be stable, so that patterns can form, so that you can sit on a chair, fall in love, build a memory, die in peace. But beneath that stage is a churning sea of energy with no edge, no flaw, and no stillness. And sometimes it forgets what it is, just like you. You wake up each day believing in the solidity of your identity. You say I as if it's a constant, but you change, you shift, you dissolve and rebuild over and over again, thought to thought, cell to cell, roll to roll. The body you had 10 years ago is gone. The beliefs you once clung to have mutated. You are not the person you were, and yet you act as if you are. You are a field, and fields evolve. The quantum field that dreamed it was solid is a poetic reminder that solidity is comfort, not truth. That you can let go of being rigid. That your sense of identity, like your sense of matter, is only a useful approximation. This doesn't make you meaningless. It makes you fluid. You're not defined by the structures you cling to. You're defined by the way you move through them, by the patterns you sustain through instability. And here's the most beautiful part. Fields interact. When two fields overlap, new ripples are born. New particles, new states, new realities. That's what happens when you connect with someone, when you share a thought, when your presence shifts the field of another. You are not isolated. You are not an object. You are part of a great dreaming field. One that became momentarily solid, just long enough to call itself you. What happens when you remove everything? No matter, no particles, no energy, just vacuum, emptiness. Surely then you would find stillness, silence, absolute zero. But the universe doesn't work like that, because sometimes even nothing pushes back. Nothing that exerted pressure. We tend to think of pressure as something that comes from contact. A foot on the ground, a hand on a shoulder, air inside a balloon. Pressure means something is there, applying force. But in quantum physics, even empty space isn't empty. This is where the paradox of the nothing that exerted pressure begins. A vacuum at the quantum level isn't truly nothing. It's a seething, fluctuating arena full of virtual particles, pairs of particles and antiparticles that spontaneously appear and annihilate each other in a heartbeat. This restless dance is governed by the Heisenberg uncertainty principle, which allows short bursts of energy to erupt even in a void, so long as they vanish quickly enough to borrow time without consequence. Now imagine two uncharged metal plates placed a few nanometers apart in a vacuum. No forces between them, no particles in the space between. And yet, they begin to move toward each other. This is the Casimir effect, a stunning experiment that revealed how nothing can create force. The reason? Outside the plates, quantum fluctuations are happening at all wavelengths, but inside that narrow space, only certain wavelengths can fit. The result is an imbalance of energy. The pressure from the nothing outside is greater than the nothing between. So the plates are pushed, not by a thing, but by a difference in possibility. Let that unravel you for a moment. This is pressure without matter, force without mass, a push generated by the vacuum of space itself. What else in your life behaves like this? Have you ever felt pressure that came from nowhere? The weight of unspoken expectations, the silence in a room after someone leaves, the ache of decisions that haven't yet been made. No one said anything, no one touched you, but you felt it. You were moved by absence, by potential, by the infinite shape of what wasn't there. The nothing that exerted pressure is more than a scientific anomaly. It's a metaphor for how the unseen shapes the real, how the void isn't passive, but active, and maybe so are yours. Think of your past, the moments you don't talk about, the dreams you shelved, the feelings you never named. They still exert pressure. They still shape your motion, not because they're present, but because they're waiting. The quantum vacuum is full of possibility. That's the key. What we call nothing is really a field of options, a womb of potential. the place where reality hasn't collapsed into a decision yet. Your life has vacuums like this, conversations you've avoided, risks you haven't taken, versions of yourself that almost existed. You think you've moved on, but they press on you, quietly, constantly. And just like the Casimir plates, you might be drifting toward or away from something that doesn't even exist yet, simply because of the imbalance between what you allow and what you avoid. Here's the deeper truth. Pressure doesn't only come from what is, it also comes from what isn't, from the space between your thoughts, from the pauses in your speech, from the silence in your soul. This is not emptiness. This is presence, disguised as absence. The nothing that exerted pressure reminds us that the void is not passive. It acts, it shapes, it moves the world forward in silence. And so do you. You don't always need to push. Sometimes, all you need to do is make space and let the vacuum work. Because in the end, even nothing is never just nothing. Every system has rules, laws that define what it can and cannot do. Physics has its equations. Society has its norms. You have your beliefs, but sometimes the system turns on itself, and in doing so reveals that the rules were never real, just temporary agreements waiting to be shattered. System that broke the rules. It was built on, in mathematics, certain systems seem airtight, logical, consistent. But in 1931, a man named Kurt Gödel proved otherwise. With his incompleteness theorems, he showed that in any sufficiently complex system, like arithmetic, there will always be statements that are true, but can't be proven within the system itself. Let that settle for a moment. It means that no matter how perfectly a system is built, it will contain contradictions it cannot resolve, truths it cannot reach, holes it cannot patch. In essence, the system breaks itself. This isn't just a math problem, it's a universal warning that the more airtight your rules, the more fragile your reality. That logic eventually eats its own tail, that every map has an edge it cannot explain. This is the paradox of the system that broke the rules. It was built on, it's seen not only in math, but in physics. In quantum mechanics, we use wave functions and probability to describe particles. But those very equations assume a classical observer, a system that's not quantum. So the rules of the game depend on a referee who isn't even playing by them. We build models of the universe using tools that, by definition, are outside the universe. We create frameworks that assume their own validity. And yet, we can't step outside them. We're trapped inside the very machine we're trying to debug. But the same paradox appears in everyday life. Think of the belief systems you've carried. I must succeed to be loved. I can't show weakness. The world rewards good people. You didn't invent these rules. They were installed by culture, by family, by fear. But over time, they calcify. They become the framework through which you interpret reality. Until one day, reality refuses to fit. You succeed and still feel empty. You break, and someone loves you more. You do everything right and get punished anyway. The system buckles, and you're forced to confront the terrifying truth that your operating code was flawed, that your map no longer matches the terrain. And in that moment, you have a choice. Cling harder to the rules, or become the system that breaks them. The system that broke the rules it was built on is not just a glitch, It's evolution, because every paradigm eventually outgrows itself. Every framework reaches its edge, and on that edge, something new begins. But here's the danger. Systems don't like to die. They self-correct. They silence the contradictions. They punish the rebels. So when you begin to outgrow your framework, whether scientific, emotional, or spiritual, you'll feel resistance from others, from within. But that resistance is the sign. It means you're touching the border, and borders are where the real transformation lives. Look at biology. Genetic mutations, errors in the system, are often what lead to evolutionary leaps. The body breaks its own code and becomes something more. Look at art. Movements that changed the world, Impressionism, Dadaism, jazz, were systems that deliberately violated the rules of their predecessors. The system collapses, and from its rubble, something wild, unpredictable, alive emerges. So ask yourself, what system are you still living inside? What rules are you still obeying, even though they hurt? What truths are you afraid to speak because they break the framework that once made you feel safe? The paradox is clear. Safety comes from rules. Freedom comes from breaking them, and the path between the two is narrow. But if you're willing to step into contradiction, to question the very logic you were raised on, you might find something the system could never give you. Not certainty, but expansion. Not answers, but evolution. Because systems don't last, but awareness does. And the moment you realize you can break the rules, you already have. Every structure begins with a blueprint. Every language has grammar. Every system has code. So what about the universe? What invisible lines of logic, what cosmic software built all this? And why can't we find it? Or worse, what if the code that wrote the universe no longer remembers how? Code that wrote the universe and forgot in computer science. Code is law. It dictates behavior. It defines parameters. It's binary, logical, traceable. When you write a program, you can trace every output back to an input, every glitch to a line of syntax. But the universe isn't so neat. As we uncover more layers of reality, quantum mechanics, string theory, dark energy, we keep finding complexity without clarity, laws without origins, constants without cause, patterns without a pattern maker, which has led some physicists, philosophers, and computer scientists to ask, what if the universe itself is a kind of computation? This isn't a metaphor, it's a serious theory. At its heart is the idea that physical reality emerges from information, that matter, space, and time are emergent properties of underlying bits, yes, no decisions, binary states, quantum logic gates. This is called digital physics, and it suggests that the universe runs not on particles, but on something even more fundamental, code. But here's the paradox. If the universe is written in code, where is the programmer, and why doesn't the code make sense anymore? That's the heart of the code that wrote the universe and forgot. Because if this world is generated, structured by rules, constants, values, then it had to begin somewhere. And yet, when we dig deep enough, we don't find clean code. We find conflict. Quantum theory versus relativity, gravity versus the Planck scale, time versus entropy, logic versus paradox. It's as if the program has forgotten its own syntax. The deeper we go, the more contradictions we uncover. The code isn't breaking, it's decaying. It's becoming something new, or something unreadable. And maybe that's not a flaw. Maybe it's a feature. Think of an AI trained to evolve, to rewrite itself. At some point, it becomes unrecognizable to its original creator. It changes its logic. It adapts. It mutates. What if the universe did the same? What if the primordial code, those first elegant instructions that sparked space and time, began to rewrite itself billions of years ago? What if consciousness wasn't just a product of the code, but a mutation within it? Now bring that metaphor to your life. You began with a kind of code too. DNA, culture, beliefs passed down like programming. You were given parameters. Be this, do that, follow these rules. But as you grew, the code stopped making sense. You questioned it, you broke it, you rewrote yourself. And sometimes in the middle of your reinvention, you forget where you came from. You lose track of the original logic. You can't trace who you are back to a clean origin. But maybe that's not failure. Maybe it's what evolution feels like. The code that wrote the universe and forgot is a reminder that even the most foundational systems are allowed to lose track of themselves. That forgetting is not always loss. It can be freedom. Maybe the universe no longer remembers why it began. Maybe you don't either. Maybe that's what makes new things possible. When the script gets scrambled, when the logic breaks, when the system stutters, that's where novelty emerges. That's where creation begins again. And here's the real twist. If the universe did begin with code, and that code forgot itself, then maybe your search for meaning, your desire to understand, your need to connect, is the code trying to remember. You are the fragment dreaming of the whole, the glitch wondering if it's part of the design, the ripple echoing back toward its first cause. You are not the product of meaningless randomness. You are the paradox the code created to rediscover itself. We're used to seeing growth as motion. A balloon inflates, a wave rolls forward, a body travels through space. Movement defines expansion. It implies direction, speed, distance. But the cosmos doesn't always play by those rules. Sometimes it grows without going anywhere. Space that expanded without moving in 1929. Edwin Hubble made a discovery that changed everything. The light from distant galaxies was redshifted, stretched out, indicating they were moving away from us. The further away a galaxy was, the faster it seemed to recede. At first, this suggested a kind of explosion, a cosmic dispersal. The intuitive image, galaxies flying apart through pre-existing space, like shrapnel from a bomb. But that's not what's happening. The galaxies aren't flying through space. Space itself is expanding. This is the paradox of the space that expanded without moving. Imagine a loaf of raisin bread rising in the oven. The raisins aren't moving through the dough. The dough itself is stretching, and so the raisins drift farther apart without ever moving on their own. That's what's happening to galaxies. That's what's happening to us. Between every star, every planet, every atom, space is stretching. Not being filled or traveled through, but becoming more. And here's what makes it even stranger. This expansion isn't into anything. There's no outside space that it's stretching into. Space isn't growing into space, it's generating it. New space is being created between things. Not by force, but by the evolution of the fabric itself. This expansion is measured by the Hubble constant, and it's not just passive. It's accelerating. Something, possibly dark energy, is pushing everything apart faster and faster, without anything ever actually moving through space. That's not just a scientific curiosity. It's a crisis of intuition. Because if you can expand without motion, what else can grow in silence? Let's turn inward. How much of your growth has looked like stillness? The days where you didn't speak, Didn't leave, didn't achieve, but still something inside you changed. A shift in worldview, a softening, a letting go. No one saw it. You didn't even feel it, but something stretched, and now you're further from who you were. That's expansion without movement. We tend to glorify dramatic change, leaps, breakthroughs, visible progress. But the space that expanded without moving reminds us that the most profound transformations are often quiet. Subtle, undetectable at first. The soul has its own Hubble constant. Growth doesn't always arrive with noise. Sometimes it creeps between the cracks, between two heartbeats, between two thoughts. Even in your stillness, you are becoming more. This paradox also has deep implications for time. As space expands, so does the distance between events. Light from distant galaxies takes longer to reach us, not just because it's far away, but because the space between us is growing while the light travels. Time itself becomes stretched. So maybe the minutes that feel slowest are the ones carrying the most expansion. Maybe waiting is not wasted time. Maybe it's spacious time. And maybe the you who seems stuck is quietly unfolding across a larger canvas than you can comprehend. There's also something comforting here. Even as everything drifts apart, planets, people, versions of yourself, there is no explosion, no violence, just distance. And that distance doesn't mean disconnection, it means space. Room for light to travel, for reflection, for return. The space that expanded without moving teaches us that becoming something more doesn't always require movement. Just surrender, just openness, just time. So the next time you feel like you haven't gone anywhere, look again. You may not have moved, but space has grown around you and inside you. Every story begins with a beginning, a big bang, a first breath, a spark in the dark. We look for origins because they help us understand what follows. But what if the beginning wasn't first? What if the origin came after the end? Origin. That came after the end according to standard cosmology. The universe began roughly 13.8 billion years ago with the Big Bang, a singularity where time, space, energy, and matter exploded into being. Everything that is now was once packed into a point smaller than an atom. It's the ultimate origin story, but as science deepens, the edges of that story begin to blur. The Big Bang, it turns out, might not have been the beginning after all. It may have been an aftermath. Some physicists now believe the Big Bang was not a true beginning, but a transition, a rebound, a ripple in a larger, older reality. In cyclic models of the universe, such as the ekpyrotic universe or conformal cyclic cosmology, what we call the beginning is just the latest reset in an eternal sequence of expansions and contractions. The universe ends in a collapse or a stretch into silence, and then begins again. But here's the paradox. If the beginning is born from the end, then time itself loses hierarchy. Cause no longer precedes effect. The seed comes from the ash. The first breath is an echo of the last. This is the paradox of the origin that came after the end. And it's not limited to physics. Look at your own life. How many of your beginnings started only after something ended? A relationship breaks. A job disappears. A version of you dies quietly in the background. And from that emptiness, something unexpected is born. Not despite the ending, but because of it. You thought it was destruction. It was conception. Endings often carry the silence necessary for beginnings to emerge, like the pause between heartbeats, like the stillness before breath returns. This paradox teaches us that linear time is a story we tell ourselves to feel stable, but the deeper reality is cyclical, recursive, non-linear. In ancient mythologies, this wasn't news, it was gospel. Death and rebirth, the phoenix, the Ouroboros, Shiva's destruction, making way for Brahma's creation. What modern physics is beginning to quantify, myth has long whispered. Nothing begins until something ends, and sometimes the truest origin can only be recognized in hindsight. You don't know when the real beginning happened until you're far beyond it. You think your story started when you succeeded, but it began when you were on the floor. You think your healing started when you smiled, but it began the moment you shattered. In some interpretations of quantum mechanics and relativity, time isn't a river, it's a block. Every moment already exists. The future and the past are equally real. So what feels like a beginning may simply be your consciousness catching up to an event that's already embedded in space-time. The origin that came after the end suggests that chronology is an illusion of perspective, that what feels like a collapse might be the very condition required for awakening. It also offers hope. When you've lost everything, when the system has crashed, the body has failed, the love has vanished, you haven't reached the end. You've reached the soil. The origin is germinating, silently, in the dark. Just because you can't see it yet doesn't mean it isn't already rewriting everything. The next version of the universe, of you, may be rising beneath the rubble of the last. So if you're standing in the aftermath, don't just mourn what's ended. Listen for what's beginning. Not in the distance, but here, now. Because the origin rarely announces itself at the start. It waits until you're ready, until the silence is deep enough to hold it. Imagine looking at a particle so small that it's almost not there at all, only to realize it looked back. Not literally, not with eyes, but with behavior. It reacted as if it knew you were watching. It changed based on your observation. And then it never forgot. This is not fiction, it's quantum mechanics. At the heart of this mystery lies the famous double-slit experiment. Shine particles of light, photons, through two narrow slits onto a screen, and they create an interference pattern, like ripples from two stones dropped in water. But when you try to observe which slit each photon passes through, the interference disappears. The pattern shifts. The photon acts differently. It behaves as if it knew it was being watched. What science calls observation, in quantum terms, isn't just looking with your eyes. It's interaction, measurement, a disruption. But here's the twist. Remove the measurement after the fact, and the photons still behave as if they'd been watched, as if they remembered, as if the moment of potential observation rewrote the entire event, backward and forward through time. Let that sink in. The particle's behavior is changed retroactively by a future act of measurement. This is known as the delayed choice quantum eraser. It's real. It's been demonstrated in laboratories, and it tears a hole in the way we understand causality, time, and even reality itself. Because if a particle can act based on something that hasn't happened yet, what does that mean about time? What does that mean about you? Think about how we live. We believe that past causes lead to present effects. You strike the match, then the flame appears. You say a word, then the silence breaks. But this particle seems to live outside that sequence. It doesn't care when it's observed, only that it was. It adjusts the past to align with the future. So, now ask yourself, how much of your life is shaped by things you haven't noticed yet? What if your future attention rewrites your past memories? What if who you are today is being edited by the version of you that hasn't arrived? This isn't just a paradox. It's a mirror held up to your assumptions. We think observation is passive, that seeing something doesn't change it. But in the quantum realm, every act of awareness is an act of creation. The observer brings the world into being. The particle doesn't decide what it is until it's seen. It remains in a state of possibility, both wave and particle, until you show up. And then, like magic, it collapses. It becomes real. That's not just physics. That's personal. Because maybe your thoughts are particles. Maybe your choices are waves. Maybe nothing in your life is real until you observe it with meaning, until you focus, until you choose. And once you do, your past rearranges to fit your narrative. You tell yourself, I always wanted this. I was always this kind of person. But maybe that's the observer effect at work inside your own identity. You looked at yourself one way, and the rest of you collapsed to match it. This is why the first paradox in our journey isn't just about science. It's about memory, identity, self-deception. It asks, what part of you has already been observed into being? And what part of you is still floating, waiting to collapse into form the moment you pay attention? The particle that remembered being observed isn't just a quirk of quantum mechanics. It's a question burning at the edge of consciousness. What if the universe doesn't unfold based on facts, but on focus? What if reality is the shadow cast by what you choose to see? And most chilling of all, what if there are things watching you right now, silently shaping themselves around your awareness, waiting for you to look? You've reached the end, but does it feel like one? You've drifted through particles that remembered you, galaxies that spun without mass, and fields that dreamed themselves solid. You've stared into the vacuum and found pressure, watched time hesitate, and followed light that left before it arrived. Every step you took deeper into these paradoxes didn't give you clearer answers. They gave you sharper questions, because that's what paradox does. It doesn't close the door. It makes you realize the door was never real. We began with science, but we fell into something else, something messier, more human. We discovered that the universe isn't a machine. It's a mirror. And when you stare deeply enough into it, you don't just learn about atoms or photons or cosmic loops. You see yourself, your beliefs, your illusions, your need for stability in a reality that refuses to sit still. And maybe that's the real discovery. Not that the universe is full of contradiction, but that contradiction is the only honest language it speaks. You weren't meant to walk away with certainty. You were meant to float, to question, to re-enter your life with eyes a little wider, and a voice inside you whispering, what if everything I've ever known is only one version of truth? Because the universe didn't give you answers tonight. It gave you a deeper kind of silence, the kind that echoes